In this lesson, we're going over how to solve log equations, so the inverse of the exponential. And we had these three problems as set up as warm-up. So if you could, go ahead and I would say pause the video and try these three on your own and make sure that you're good to go with this equation and properties of our logs here. And here we go. So with the first one, you should have noticed this is an exponential. So you're not going to divide by 4, right, to get 5. This is an exponential. X is in the exponent. So you have to write it as a log by itself. So log base 4 of 20 is equal to 2x. So now notice change of base here, right? So this is log 20 divided by log 4 here, which gets you approximately 2.2, which is equal to 2x. So you divide by 2 and you get approximately 1.1. Then here, this is just a review on change of base. Now notice though, this is log 5 divided by log 25 because the base needs to go in the bottom and you get 1/2. Then here, you're not adding, right? So you're not going to get log base 6 of 12 when condensing. Remember, adding meant multiplying. So this is log base 6 of 32. So now change of base, you have log of 32 divided by log 6, and you get approximately 1.9. So now here, there's times where solving the log equations where you could use change of base, and that could be your first step here to solving the log equation. Now, only one of these three shown is the first step is that you can actually apply change of base. The other two, you actually will have to rewrite it as the exponential. So which of these three do you think is going to actually be able to apply the change of base? The second one, because notice how you have the two values here, right? Log base 8 of 145. This is log of 145 divided by log 8 and get your answer. Because now notice here, right? If I were to do change of base, well, that's log of x divided by log 4. Well, do we know what x is? No, that's what we're trying to solve for, right? So really, this is not going to help with getting that answer here. So when you can't do change of base and see how we have a log, then we're going to write it as an exponential. So again, the base is 4. So 4 to the what power? Again, big circle, right? So 4 to the 3.3 is equal to x. So now notice that's just 4 to the 3.3 power. So putting that in the calculator, you get approximately 97. So then here, again, the base is x. So x to the what power? Second power is equal to 24. Now notice we're back to solving a quadratic, right? That's x to the second power. So what would you do to solve for x? Take the square root. So this is x is equal to plus or minus. Simplify that radical 24 and you can get to radical 6 here. So again, it's if you can use change of base, then go for it. Otherwise, we're going to have to solve the log. And then, of course, if the log is not by itself, get it by itself, just like the exponential. So like in 1a, can we do change of base? Yes, we can. That is log of 9 divided by log 4.5. So go ahead and pause the video and put that in the calculator and see what you get. And so here, when you do the change of base, you get approximately, we'll round it to the nearest 10, so 1.5 is equal to x minus 1. So now add 1, and x is approximately 2.5. Now here, can we use change of base? No, because notice how x is within the log here. And this is a common log, so the base is understood to be what? 10. So here we've got a base 10. So 10 is being raised to the what power? 1.3. So 10 to the 1.3 is equal to what? Not just x, right? X minus 4. So now here, 10 to the 1.3, you get about 20 is equal to x minus 4. So x is approximately, add 4, get approximately 24. Now notice here we do have a log. It's just a natural log, but it's being multiplied by 5. So we got to get it by itself. So what are we going to do? Divide both sides by 5, right? So now here we've got the natural log of x plus 4 is equal to 1.6. Now, we've got a natural log here. So same as before, what is the inverse of our natural log or ln? E. So what we do to one side, we do to the other side here. So now canceling out, bring down x plus 4. Oop, not x plus 14. Sorry about that. So now here, x plus 4. So again, now, right, raise that e to the 1.6 power, and you get approximately, we'll say about 5 here, because I got like 4.95. Then subtract 1, and x is approximately 1. Or if you put 4.95, you subtract, and you get about 0.95. So if that's your approximation. So go ahead and pause the video and now try the 2 U tries on your own. And here we go. So notice, can't do change of base because x is within the log here. So convert it. The base is 4. 4 to the what power? To the second power is equal to x plus 3. So now 4 squared, well, that's 16, is equal to x plus 3. Subtract 3, you get x is equal to 13. So then here, could you do change of base? Absolutely. So here, you do change of base, right? Log 12 divided by log 11. You get about 1.04 is equal to x minus 7. So now here, add 7, you get approximately 8.04 for x. So now what if you have multiple logs? So we're going to start with if the multiple logs are on the one side. So see how we have 2 logs here, same base. So we're going to use the property. We're going to write this as 1 log and condense. This is log base 4. Now, adding, so do we add? No, we're going to multiply. We're going to multiply 2 times the x plus 6 here is equal to 2. So now here, now really what we're looking for is log base 4 of 2x plus 12 is equal to 2. Now we can solve this and convert to our exponential. So what is the base? The base is 4. 4 to the second power is equal to 2x plus 12. And now we're solving. 4 squared is 16 is equal to 2x plus 12. Now you're just solving a 2-step. Subtract 12 here from both sides. You get 4 is equal to 2x. Divide by 2, and you get x is equal to 2. The same thing here. See how we have multiple logs on the same side, but they're being subtracted. So what does subtraction mean? Dividing. So we have our log base 8, right? Bases are the same. But now we have x plus 1 divided by 100 is equal to 1. Now write it as an exponential. So what is our base? Base of 8. 8 to the first power is equal to our fraction, x plus 1 over 100. So, well, 8 to the first power is just 8. So now we're going to go through and solve. Now, see how we have the fraction? Get rid of that. So if I'm dividing by 100, multiply both sides by 100. So now I've got 800 is equal to x plus 1. Subtract 1, you get x is equal to 799. So again, with the multiple logs, you got to first condense them using our properties, then go through and convert and solve for x. So go ahead and pause the video now and try the 2 U tries on your own. And here we go. So notice here for the first one, bases are the same on the same side. So we're going to write this as 1 log, log base 3. You're adding, so don't add, right? 6x plus 2, multiply 6x times 2, which gives you 12x, and that is equal to 2. Now write it as an exponential. So your base is 3. 3 to the what power? To the second power is equal to 12x. 3 squared is 9, which is equal to 12x. And then so last here, divide by 12. So now here you've got this fraction, which can be simplified to 3/4 or 0.75. Then here, again, same thing, right? Multiple logs on the same side. So log base 2, now subtracting, so we're going to divide 2x divided by 5. That is equal to 4. Now we can convert. So what is our base? Base is 2. 2 to the what power? 4th is equal to the fraction 2x divided by 5. Now we can solve. 2 to the 4th power is 16. That is equal to 2x over 5. Now notice you have a fraction. So what do we have to do? If it's a division, multiply by 5. So now here you get 80 is equal to 5's cancel out, right? You're left with 2x. Divide by 2, you get x is equal to 40. And so now here our last type of log equation is we have multiple logs, but what if they're on both sides of the equation, right? Now notice they're not on the same side, they're on different sides. This is like the same property that we used with the exponential. So like let's say we had e to the 4x minus 7 is equal to e to the x plus 5. Well, what was the property? If the bases are the same, they just cancel each other out and bring down and solve the exponents. It is the same property for our logs. See how there are both a natural log? So guess what happened? They cancel each other out. And now you're just solving for x minus 7 is equal to x plus 5. So again, when they're on different side or when they're on the same side, we have to use our property. But if they're on different sides, they cancel out and we solve. So now I've got my multi-step. I'm going to gather my x here, subtract it. 3x minus 7 is equal to 5. And now we're just solving a two-step. Add 7 to both sides. 3x is equal to 12. Divide by 3, and x is equal to 4. So same thing here. Can we cancel out the two logs? Absolutely. Same bases, and they're on different sides. So really we're solving 6x is equal to 4x plus 5. So now go ahead and gather your variables. So we're going to subtract 4x here from both sides. And I've got 2x is equal to 5. Divide by 2, and you get x is equal to 5 over 2 or 2.5. So again, go ahead now, pause the video and try this. You try on your own. And here we go. So again, can we cancel out the two logs? Yes, because they're both a common log. They both have a base of 10. So here the logs cancel out and you just solve 3x minus 5 is equal to 2x plus 1. So now you had to gather the variable and subtract 2x here from both sides. You have 1x or x minus 5 is equal to 1. Add 5, you get x is equal to 6. So now it's just these practice problems. So go ahead and pause the video, go through these practice problems on your own, and then I'll go through these quickly so that you can check your answer and make sure that you're good on these problems. And here we go. So for the first one, you just have the 1 log. So here we'll rewrite it as an exponential common log. So the base is 10. So this is 10 to the second power is equal to 2x plus 20. 10 squared is 100. And that is equal to 2x plus 20. So when you solve your two-step, subtract 20, you get 80 is equal to 2x. Divide by 2, you should have gotten b. Now here you had to first divide by 3 to get the log by itself. So log base 6 of 2x minus 1 is equal to 2. Now convert it to an exponential. Base of 6 to the second power is equal to 2x minus 1. 6 squared is 36 is equal to 2x minus 1. Now you got to slow down with this one, right? Don't subtract 1, make sure to add 1 to get 37 is equal to 2x. Divide by 2, that's how you get a. Then here you have multiple logs, but they're on the same side, so we need to use our property to condense. Log base 2 of 4 times x, right? Because you're adding. So this is 4x. That is equal to 3. Now convert. So this is a base 2 to the third power is equal to 4x. 2 to the third is 8. 8 is equal to 4x. Divide by 4. That's how you get C. So then here, your natural log, not by itself. So you had to first divide by 7 because it was being multiplied. Natural log of x is equal to 5. So now the inverse of ln is e. They cancel out. You get x is approximately e to the 5th power, which is about 148.4. So now here, do the logs cancel out? Yes, because they're on different sides and the bases were the same. So 5x plus 1 is equal to 2. Now solving, subtract 1. You have 5x is equal to 1. Now make sure you are supposed to divide by 5. So x is not equal to 5, x is equal to 1/5 or 0.2. So then the last one here, log is by itself. So you have to rewrite this. Again, common log, base 10. So this is 10 to the third power is equal to 5x minus 15, which is 1,000 is equal to 5x minus 15. So now here, solving your two-step right, add 15, so you get 1,015 is equal to 5x. Divide by 5, you get x is equal to 203. So then this last one here, given the situation where V is the value, T is the time in years of the car. She wants to know what's the value, how to rewrite this to figure out the value of the car. So we're solving for V. Well, you have a log, so rewrite it as an exponential. So what is the base? 0.8. 0.8 to the what power? To the T power is equal to the fraction V divided by 17,000. So now to solve for V, it's being divided. So what is the opposite of division? Multiply by 17,000. So you multiply by 17,000. That's why the answer is B.